Good afternoon. My name is Elisabetta Ranucci. I'm professor at the University of Milan. My colleagues from the Milan Polymer Days group join me to welcome you to the second event of the Talking with the Scientists program. The purpose of this initiative is to interview renowned scientists on hot topics of interest to ordinary people and to stimulate their active participation of the audience. Today it is a special day since Professor Sabu Thomas, Vice Chancellor of the Mahatma Gandhi University, Kottayam, Kerala, India, will discuss on a very interesting topic, the use of agricultural waste for producing nano-sized materials that can be used for the synthesis of new advanced plastics. Professor Sabu Thomas is not only a great expert in the field, but is also a worldwide renowned scientist. Recently, the Stanford University, USA, recognized him as the second most important scientist in the field of polymer science from India, and his world ranking is 114. Professor Sabu Thomas will be interviewed by Andrea Dorigato, a young professor from the University of Trento, Italy, who is also expert in the field of material scientists. Before leaving the floor, to the main protagonist of this event, I'm pleased to inform the public that the videos of the Talking with the Scientists series will be available on YouTube and are accessible from the Milan Polymer Days Facebook. For the time being, I kindly encourage you all to participate in the debate by submitting questions to the speaker. At the end of the talk, we will take your questions into consideration and we will comment on them. So now I wish you all a very interesting debate, and I kindly ask you to participate in the discussion. So now, please, Andrea Dorigato, yours is the floor.
Thank you, Elisabetta, for the nice presentation, and good afternoon to everybody. It's a pleasure for me to be here for this nice and innovative event, and for the second event of this interesting initiative. We will have the Professor Sabu Thomas that will give us a presentation and an interview entitled Nano from Agro-waste and their Composites. This event is organized by the Milan Polymer Days Scientific and Organizing Committee, and it's a pleasure for me to be here to do some questions to such an eminent scientist. What is the scope, the aim of the presentation? Just 2 words about the summary of this presentation. We know that there are some important biopolymers from agro-waste, and the most important polymer in this sense are probably cellulose, chitin, chitosan, and starch. We know that we can derive cellulose nanoparticle or nano-based material based on cellulose, extracting them from different vegetable material, vegetable wastes, for example, jute, coir, bamboo, and other vegetables. Or we can also derive some nanoparticles of chitin, or we can also obtain some starch nanoparticles. It's important to underline that we can process through some chemical modification like surface functionalization this nanoparticle, the surface of this nanoparticle, and we can use them as a filler or as a reinforcement in different kind of polymer matrices in order to produce multifunctional and smart nanoparticles. It's also important to underline that the multifunctionality of this material, of this new and multifunctional material, can be characterized both from a microstructural, thermal, and mechanical point of view. So after this brief presentation, I would like to introduce Professor Sabu Thomas. As Elisabetta said before, Sabu Thomas is a vice chancellor at the Mahatma Gandhi University in India, in the region of Kerala. And he works in different research areas, in nanoscience, in polymer fields, polymer science and technology, nanocomposites, polymer blends, polymer membranes, and in development of green composites and nanocomposites. Professor Sabu Thomas is an eminent scientist in the international scientific framework because he received more than 30 national and international awards. He's one of the most productive and important research in India. It is the second researcher in the polymer science. He was awarded honoris causa of the Doctor of Science title in 3 different universities, in the Laurent University in France, in the Sea University in France, and also in the Siberian University in Russia. For as concern his scientific production, it's important to underline that he published 1,200 peer-reviewed papers, reviews, and book chapters. He was co-editor of 140 books. He was an inventor of 15 patents. His H index is more than 100, 106. And he has more or less 53,000 citations. He delivered over than 350 lectures and invited lecture in national and international conferences, and he supervised more than 100 PhD students. So I'm impressive, an impressive CV. And now I am very curious to ask something to Professor. The first question to Professor is that you are a professor of polymer science in your university. What do you teach there? And what kind of research do you conduct in this university?
Thank you. Thank you for the nice question. I teach polymer science and nanoscience and nanotechnology at the university. And if you look at my research, I do extensive research on extracting nanoparticles from agricultural waste, nanoparticles from fish waste, nanoparticles from agricultural starch waste. In addition to, I also do a lot of work on synthesis of new nanoparticles, metal oxide, graphene, carbon nanotube, and I put these materials into polymers, plastics, rubbers, and thermosetting materials, and to make high-performance polymer nanocomposites for various applications, for tissue engineering, for water purification, for EMI shielding, for batteries. We develop a large number of advanced composite materials for a variety of end-use applications.
Okay. And now another general question. There are many definitions about nanoscience and nanotechnology. We know that you are a real expert in this field. So can you give us a clear and simple and comprehensive definition of nanoscience and nanotechnology?
Nanoscience and nanotechnology is a science of extremely small particles, very, very small particle, 1 by 50,000 with the diameter of human hair. That could be a very nice way of explaining nano size. And why nanoparticles show this sort of unusual properties? Because you are talking about atomic surface. And the surface to volume ratio is extremely high. And you have a lot of confinement effect. And because of these, nanoparticles show unusual properties. I can give you a very good example. You take gold. Gold has a golden color. Gold is conductive. But if you go to nano size, the properties of gold is completely changed. Gold becomes no more conductive because you increase the band gap. And you can have different colors of gold, blue gold, green gold, yellow gold. You see, you completely change the properties of nanomaterials when you go to nanoscale. This is basically because of the high surface to volume ratio and nanoscale confinement. I can give you a very simple example. Look at lotus leaf. Lotus leaf shows the so-called lotus effect. And when you examine the lotus leaf under high resolution electron microscope, what you really see is you see millions of hairy nanocrystals. And these crystals are made of hydrocarbon. Therefore, lotus leaf is extremely hydrophobic. When water falls on the lotus leaf, it forms a droplet. It cannot form a film because there is high interfacial, contact angle, high interfacial tension between water and the lotus leaf. And this is what is the lotus effect. And the water rolls and rolls and goes down to the earth, taking all the debris. You see how nature engineered the lotus leaf. And looking at the lotus leaf, man has made something very interesting. You all must have heard about wiperless car. These windglasses are made of glass coated with very excellent hydrophobic material. So now we can drive car without wipers, the way man learned from nature. So my humble request to all of you is look at the nature and you learn from the nature. Another example I wanted to tell you is a gecko. If you examine the palm of a gecko, you have millions of nanotubes. And these millions of nanotubes provides the gecko the ability to adhere to the surface. And man's understood this, and man has made gecko tape adhesive. So these are some of the simple ways of explaining nanoscience and nanotechnology.
Okay, very inspiring definition. And we have already said that you are a vice chancellor in your university, and you are probably involved in many programs towards the internationalization programs and process of your university. Can you explain us what are your real efforts in the internationalization process of your university and of your institution?
My view of my institute, transforming Mahatma Gandhi University into an excellent place for teaching, excellent place for learning, excellent place for research, excellent place for dissemination of knowledge to society, extension activities. And my first important point is publish high-ranking papers in high-impact journals. That is one way of internationalizing the institution. High-impact publication. You see, I have 1,200 publications, and I have many high-impact publications. That gave us lots of internationalization. Second important point is patenting. If you find something interesting in the laboratory, I always tell my PhD students, go for a patent. The philosophy in the lab is invent, patent, publish, and commercialize. The third important way I internationalize the university is large exchange of students and faculty members. I invite many students to our campus, and my students go to other universities. I invite many faculty members to our campus. Our faculty members travel abroad, and I always conduct a large number of conferences, meetings, symposia. Last week, we had an excellent conference. Elisabetta was one of our plenary speakers. So every year, I organize at least 5 or 6 international conferences. Therefore, our group is known all over the world. You name any country in the world, I have at least 10 to 15 very, very good academics as my friends. We are also planning to have new courses, new programs like artificial intelligence, robotics, data science, IoT. We are going to start in the campus. That will attract lots of students. We have a wonderful program on nanoscience and nanotechnology. So my interest is to invite large number of students into Mahatma Gandhi University, and Mahatma Gandhi University will be transformed into an excellent place for teaching, research, and extension. And I'm sure our university will be within 500, in a global ranking, and within 10 in the country very soon.
Okay, good. Another general question. Your CV is impressive. Honestly, it's impressive. And probably these important results that you are able to give an important contribution in international scientific and industrial framework. Probably these results derive from a careful organization of the work and on a well-defined working methodology. So can you explain us briefly what is the organization of your research group and how important it's for you the team working in the research field and in all the research activities?
You know, the success of my career is because of the teamwork. You know, I inspire my group members, I motivate my group members, I encourage my group members, I educate my group members, and I trust all of them. So mutual trust, mutual respect, that actually give a lot of enthusiasm for my PhD students. I give them free space for thinking. That has really initiated critical thinking among my PhD students. Innovative approach. That is the success of my approach. And because of this, you know, I could supervise 115 PhD students. And my PhD students are actually working in industry and academy, India and abroad. And I have lots of cooperation with my PhD students. And that is a success story of my academic career.
Okay. And a last general question about the present work and about the future of your work. What are you currently working on in this moment, and what are the research plan for your future?
My future program is to develop large number of polymer and nanotech products or polymer nanocomposite materials for health. That's a very important area of mine. Scaffolding material for wound healing applications.
Okay.
Drug delivery. That's a very important area of my research. Second area of research is use nanotechnology and polymer nanocomposite for energy. Environment, water purification is a very important area of my research. I mean, water is going to be a very scarce material, the whole globe. So we are developing new membranes for water purification using nanotechnology and using polymer science. Another important area of my research is food security. You know, preserve food, you know, by giving nanoscale coating, edible coating for food materials. And my group is also very active to develop new advanced material for infrastructure, automotive, aerospace. So we have a big dream list of things. I'm sure within 5-6 years, we will come out with a lot of nanotech products in the campus. See, we have started a company in the campus, and we are going to start commercial production of nanocellulose, nanocrystals, nanochitin, and nanostarch in the campus. You can see that within 5 to 6 years, we will come out with lots of nanotech products for the humanity.
So I can see that you have a very wide and ambitious program for the future. And now I would like to give you some more technical questions. The first one is that in which way do you think that nanoscience and nanotechnology can contribute to our society and to the societal issues?
I think the most important contribution of nanoscience and nanotechnology is towards health. We are going to have effective treatment for cancer therapy. You can load our medicine to nanoparticles, and you can load and correct tissues. That is targeted drug delivery. That is going to be very, very important. A PhD scholar of mine, she delivered AIDS drug using nanotechnology and nanomaterials for wound healing applications. So very important area of nano is nano for health. The second important contribution nanotechnology is nanotechnology for environment, nanotechnology for water purification, My research group has made beautiful nanoscale filters for purifying water. And energy sector, nano is going to play a very important role. So we are going to make nanoscale material for battery applications, nanoscale material for anode for batteries, and nanomaterials for information technology. So these are some of the areas where nanotechnology can help humanity. And there is going to be a lots of business opportunity for nanoscale materials. If you look at the recent ACA statistics, they said $340 billion business for new nanomaterials. Information technology, they're $300 billion. Biotechnology, $180 billion business. Catalysis and manufacturing, $100 business. Healthcare, $30 business, $30 billion business. Aerospace, $20 billion business. There is dramatic effect in all fields of science and technology using nanoscience and nanotechnology.
Okay, another question that is strictly connected to the previous one. What do you think the future of nanoscience and nanotechnology will be able to tackle and to solve the societal challenges for the future?
You are right. Nanoscience and nanotechnology will be able to take up the challenges of the society. I would say there is a great contribution to health, great contribution to energy, great contribution to environment, nanoscale material for air purification, nanoscale material for removing impurities from soil. Our soil is increasingly polluted. Our air is increasingly polluted. Our water is increasingly polluted. So nanotechnology has a very strong role for safeguard our ecosystem, safeguard our health system. And energy is going to be an important issue. The population is going, increasing. Therefore, there's a great demand for energy. So nanoscale materials will be an answer for the energy requirement for the humanity. So I strongly believe that nanoscience and nanotechnology has a remarkable scope, tremendous scope for the coming generation.
Okay, and now we can go further with the other technical question, more related to the strictly connected to the agro-waste, okay, to the nanomaterial deriving from the agro-waste. In what way do you think that nanomaterials derived from the agro-waste can contribute to the development of the future society and to solve societal challenges in the future?
That's a very interesting question. You look at 1.6 billion tons of agro-waste is being accumulated every year around the clock. And this could be agricultural waste, this could be fish, waste from the fish industry, this could be starch. And many developing countries like India, China, Brazil, these agro-waste are not being utilized effectively. And lots of agro-waste is being wasted. Therefore, it's very important that these agro-waste have to be utilized for making advanced materials. I would say the biomass, that is the principle of circular economy. You make use of the biomass, transform biomass into advanced materials, and use this material for societal applications. So there is tremendous scope in using agricultural waste. Look at India, look at Kerala, we have lots of agricultural waste, we have plantations of pineapple, and these pineapple leaves are actually not being utilized in a wise manner. Look at our banana plantation in Kerala. We have lots of banana, the plantation after harvesting, all the banana stem are wasted. Look at coconut, there are a lot of waste from coconut plantation. So my idea is make use of all these agricultural waste and transform them into advanced nanomaterials. Similarly, look at the fish industry. We have a very big shore. For Kerala has a very big shore and lots of people work in the fish industry. And we can make exciting material, chitosan and chitin, nanochitin. Very interesting. So my research focus will be more on agro-based materials. To make nano from agro-based materials, I strongly believe that nanocellulose will be the most important nanoscale material for the coming years. So we are going to make wonderful materials. Nanocellulose for water purification, nanocellulose for wound healing applications, nanocellulose for energy applications, nanocellulose for water purification, so nanocellulose for air purification. So we are going to make lots of wonderful things out of nanocellulose.
Okay. Now I would like to give you a question that is strictly connected to my research topic. So you talk about the nanomaterials and nanotechnologies deriving from agro-waste. What do you think that in the future the development of this nanostructured material can support, if any, the development of new structural materials, so materials that are able to sustain loads?
You're right. You see, nanomaterials derived from agricultural waste are eco-friendly, biocompatible. Look at nanocellulose. If you look at the strength and modulus of nanocellulose, it can beat many of the synthetics. So I'm sure that this is one of the most promising nanostructured material because this is renewable and you can get fantastic properties. Look at the surface chemistry of this material. They have beautiful hydroxyl groups. So a chemist can do wonderful chemistry on the surface. You can go for lots of chemical modification because of the hydroxyl groups. So that will give a lot of opportunities to make advanced functional materials. And I strongly believe that these bio-nanomaterials will be the future for the society to make functional advanced materials for multiple applications.
Okay. The last technical question is related to the environmental sustainability of these nanomaterials. To what extent these biomaterials and these nanoparticles and the relative composite are really sustainable from an environmental point of view? I give you this question because I have already seen before that we need some chemical processes in order to obtain this material, to purify this material, or to surface or to treat the surface of this material. So what do you think about the environmental sustainability of this material and obviously of the relative composites?
This is a very interesting question. My research group, you see, in the beginning, we were always using acid hydrolysis to wash away all the amorphous part. Now we are moving towards more processes using microbes. So I'm sure within a few years we will be able to develop microbial assisted technology to eat away lignin heavy cellulose. And if that has been made successful, I'm sure this is one of the best techniques. If you use acid hydrolysis, that is not very eco-friendly. You have to recover all the acid. We are thinking of doing cryo grinding, cryo crushing, coupled with microbial transformation. And if you can do that, I'm sure this could be the future of the world. Making use of biomass, transforming biomass into advanced material using microbes, that could be the future. I fully agree with that. Functionalization using strong acid will have a deleterious effect to the ecosystem. So my research group is moving towards more of microbial transformation. Use microbes to eat away the lignin cellulose and try to get nanocellulose, and then use green chemistry for functionalization process. Recently, you can see our recent publication in ACS. What we did is we used green chemistry to make the surface of nanocellulose more of electronegative. We also designed some nanocellulose for mask recently by using green chemistry. So one has to use green chemistry, one has to use microbes for developing functionalization and developing advanced nanostructures from biomass.
Okay, I do not have other question, and I have to say that your answers were comprehensive, very clear, and inspiring for the future. Probably also for the public, you gave an innovative point of view that could be helpful also for their research. Now it's time to the question coming from the public, and probably Elisabetta Ranucci will enter in the discussion, and me and Elisabetta Ranucci will collect the question coming from the public, if any.
Okay, here am I. At the moment, I'm looking at the chat, but I'm not seeing any comments from the public, so they have still time to ask questions. I'm sure that Professor Sabu will be very pleased to comment on them. So if there are no questions from the public, from the audience, I would have so many questions, because this is the right time to ask a real expert, and he will explain a lot. From your perspective, do you think that this polymer, bio-based polymers or composite from renewable resources, do they have a possibility to become bulk products of the of the chemical industry in the short range time, or should we wait a lot until they become a reality as commodities, as marketable materials? So are we far from the practical application, or they are a real possibility for the market? Do they have a possibility?
My answer is there is great possibility coming up. Look at the important biopolymer that we have in Kerala, natural rubber.
Okay.
And possibilities for natural.
Okay.
Kerala is 99% rubber. Look at the nanocellulose derived from agricultural waste. You know, in the 90s, what I used to do was chop this natural fiber, this microfibers, and use it for automotive applications. Now we are more into high-tech applications. Nanocellulose for EMI shielding is a very important material. Nanoscale material for EMI shielding. You know, we have made nanoscale, beautiful nanocellulose, then we have polymerized aniline. So this is getting commercialized. So there are several products going to be commercialized. I'm sure these materials are a tremendous future. Nanoscale material derived from agricultural waste, the biopolymers, and combine this nanoscale material from agricultural waste mixed with the biopolymers. That will have to come and just.
Then a second. Sorry.
And what? Yeah.
And if I can ask a second question, and what is your opinion about the possibility to combine conventional plastics with bio-based fibers? Do you think that this is a good approach, or is it something that we should forget, maybe for some technical or environmental reasons? For instance, for problems associated with recyclability. So what is your opinion?
I'm very positive about it. You know, my research group has mixed 80% of microfibers. 80% of microfibers into polyolefins. And you see, then we have a very small content of polyolefin, polyethylene, polypropylene. We were able to mix using intensive extruders. We were able to mix 80% of microfiber, cellulose fiber, not nano, with polyethylene.
Yes.
That is very interesting. So the amount of plastic could be reduced. If we can have very intensive mixes, we can definitely do that. That is very promising. And we also made use of nanoscale material for reinforcing several. See, right now I am working with the tire company using nanocellulose for reinforcing tire tread, replacing carbon black. It's a very important point. See, carbon black is very polluting. So therefore, we have entered into a cooperation with a tire company, use nanocellulose, reinforcing tire tread. Using nanocellulose, we are also going to manufacture inner tube, inner liner. Therefore, there is a tremendous scope combining these biomaterials, bio-nanomaterials with synthetic polymers.
Okay. What about the recyclability of these composite materials?
This is a very interesting question. If you look at thermoset, the recyclability is rather difficult. But if you look at thermoplastics, we work with the PLA, we work with the PCS, several thermoplastics with nanoscale bio-nanomaterials. They are fully recyclable. You can reuse it, you can recycle it. And I'm also working with cellulose with other synthetic polymers. You can recycle them, but we need to have a very good management practice. In India, we recycle lots of polymers. Okay. A lot of polymers we recycle. Yes, recycling activity is quite aggressive in India.
Then I should have so many questions, waiting for some questions from the audience. But another question, if you have expertise in using biomass for extracting or producing building blocks that can be used by the chemical industry, and if, for instance, by depolymerizing natural polymers, and if you think if this is, this approach has a future.
It's a very good question. You see, you depolymerize natural polymers or synthetic polymers, you make monomers, and then you make develop new functional materials, new polymers. That's a very good approach. You see, I have another approach. Use vegetable oil, and then you synthesize new polymeric system. You can make wonderful polyurethane. You can make wonderful polyesters. Epoxy starting from vegetable oil. So that's again a very interesting approach. And then you recycle all the polymers, or you extract monomers from these polymers, and that could be utilized for manufacturing new polymer systems. So all these approaches can be adopted. Only thing is we have to look at the life cycle analysis. We have to look at the cost performance ratio. These are very important.
Mm-hmm. Okay.
So if you look at PET is very countries in India too. We actually recycle PET and we extract, the monomers from there, and then we make new PET. Polyurethane also to some extent is successful.
Mm-hmm. Okay, that is very extremely interesting. And since we know that you are a worldwide renowned scientist, so you have many contacts with scientists from all over the world. From your perspective, if you look at the rest of the world apart India, how people are aware, scientists and society are aware of the importance to look at renewable resources. So how much are is the world, so the different nations actually involved in research based, focused on the exploitation of biorenewable resources for making plastics? So I understand that Indian society is very scientific society, is very active in this respect. And do you think that the rest of the world has the same attitude or not?
I think the world is moving towards that direction. Look at the plastic waste accumulate all over the world. I think the world is moving towards circular economy, biorefinery approach. I think that is the only way we can safeguard our ecosystem. I interact with many agriculture farmers. and tell them to utilize the agro-waste material, for end-use applications. As a scientist, as a teacher, as a researcher, you have a big responsibility to interact with society and also educate them, to collect all this agricultural waste, and this could be a lot of industrial opportunity. Now, right now, I am working with a company in the agricultural, sector, the cooperative sector. They have lots of pineapple plantations, so I am advising them to make microcellulose out of it. And then my university will be able to buy it and transform into nanoscale materials. Therefore, it is very important that university faculty members to interact with society and disseminate the knowledge. I'm sure the whole world is moving towards green materials, green chemistry, circular economy, and biorefinery.
Okay, and then an important question is what about the economic point of view? What about the economy of these materials? So can they compete with conventional materials or not? Because we are all aware that a constraint for the development of new sustainable materials is that they do not well compare with conventional ones as regards their costs. Not only that sometimes, but for sure the cost is a constraint.
This is a very important question. Look at PLA, all these, biodegradable polymers. They cannot compete with synthetics. They are costly. I agree with you. The cost performance ratio has to be worked out, and we have to look at our Mother Earth, how to sustain the Mother Earth. Therefore, we have to work out a proper cost performance ratio. I'm sure if you go for bulk manufacturing, things will become more cheaper. Look at nanoscale material. I remember when I started working with clay was so expensive. Now the price of clay has gone down. Nanoscale CNT or graphene became more cheaper. I think if there is concerted effort and a lot of interconnectivity with different nations, I'm sure we can make these materials much cheaper. And then we can compete with synthetic materials. Of course, we have to really look at the cost performance ratio. That is very, very important. And however, there are a lot of drive, worldwide, to make these materials more efficient so that the cost of production could be reduced. I'm sure within a few years, several green polymers will be cost competitive with respect to synthetics.
Okay, Andrea, do you have any other question for?
I have to say that we have some questions from the public, so I will ask something to Professor Thomas. The first question is, what are the advantages of bio-nanocomposites over traditional composite materials?
You see, if you look at bio-nanocomposites, the reinforcement, fully green bio-nanocomposite, the reinforcing material is bio-origin. And the matrix is also green material. For example, we work a lot on natural rubber. It's a biomaterial which is obtained from the plant, and we fill with nanoscale materials, cellulose, so both are completely green. And if you don't cross-link it, natural rubber is biodegradable eventually. So bio-nanocomposite, what I mean is, you have a biocompatible polymer which is completely green, and you have a filler material which is also extracted from the nature. So this is a truly green bio-nanocomposite.
Okay.
And if you look
another
at the
question. Excuse me. Do you want to add something?
If you look at the conventional composite, you see the matrix will not be biodegradable, and the reinforcing material will be of synthetic origin. So that is a conventional composite. For example, glass fiber reinforced polypropylene. This is fully synthetic. On the other hand, cellulose fiber reinforced PLA, cellulose fiber reinforced natural rubber. it is a green, composite. Please ask.
Okay, another question from the public. What is the efficiency in converting agro-waste into nanocellulose? And also, we would like to know if is it a cost-effective process?
If you look at the efficiency of converting agricultural waste in nanocellulose, look at our production in using banana stalk. The yield that we go to us, if we start with 100 grams of macro banana stalk, we end up in something like 40 grams of nanocellulose. If you're going for nanocrystal, you get very small amount, but the yield is very good. Now we are working out methodologies so that the processing cost could be reduced. So we are able to, I'm sure within 4 or 5 years, we will be able to manufacture nanocellulose in a very cost competitive way, and it can compete with many of the nanomaterials like carbon nanotube or graphene or such materials. I'm sure within a few years we will work out really cost competitive processing techniques.
Okay, another question from the public regarding nanochitin. Could you please give us more insights on the potential of this nanochitin in comparison to other more traditional nanomaterials like carbon nanofibers?
You see, the beauty of nanochitin is nanochitin has a nanostructure. Its diameter could be something like 30 or 40 nanometers. And nanochitin has beautiful functionalities. And it can, the surface area is so high, surface to volume ratio is quite high. And because its functional groups, nanochitin can, catch metals. You can utilize these materials for purifying soil, purification of water, because surface to volume ratio is so high. It has got fantastic, functional groups. It can catch many metals. It can catch many carcinogenic materials. So it's a wonderful material. It's also very useful for wound healing applications. Again, it's a very interesting material for, you can make the surface of nanocellulose hydrophobic. What you do is you do a small chemistry, you introduce hydrophobic groups. Then it could be a very good structural additive for oil. So you can engineer a wide range of materials using nanochitin. You can have extremely hydrophilic, you can have extremely hydrophobic. So this is a very useful material for a large number of applications. It is very useful for sustained drug release. So I would say it's a very exciting material.
Okay. Another question regarding the durability of this new composite filled with this nanomaterial deriving from the agro-waste. So it is possible to compare the lifetime and the durability of these composites deriving from the agro-waste with that of traditional plastics or traditional fiber reinforced plastics?
This is again a very interesting question. One of the drawbacks of these nanocellulose or nanochitin or nanostarch is, their surface is extremely hydrophilic. So the water absorption would be quite high. But you can make the surface hydrophobic by doing chemistry. So my answer is, you can engineer the required surfaces by using proper chemistry. So you can make it hydrophobic, you can make it hydrophilic. So if you can do a good chemistry, I'm sure the durability will be improved. Durability could be as good as synthetic materials. So chemistry is a central part of this science. If you have a good chemist, and I'm sure you can make excellent surfaces, and that can really control the durability of the material.
Okay. Another interesting question from my point of view regarding the application of these biocomposites and nanocomposites in 3D printing applications. So the possibility to use and to apply 3D printing technology in the biocomposites and nanocomposite material deriving from these agro-wastes.
This is again a very interesting aspect. 3D printing, we have done some work with nanocrystals using 3D printing. With the PLA, a very nice work has been reported for 3D printing. So definitely we can use nanocellulose and nanocrystal, particularly nanocrystal for 3D printing. So we are actually doing some nice work. We have a 3D printer in the laboratory. So we have ambitious plan of using nanocrystals for 3D printing of PLA and PCL and such polymers. So this is a very promising area. Similarly, we are also doing a lot of electrospinning, putting nanocellulose and nanocrystals. We are probably focusing more on nanocrystals. We do PCL and PLA and do electrospinning. And we are able to make wonderful healing material. We are able to make wonderful base for drug release. We are able to make excellent membrane for water purification. So both 3D printing and electrospinning offer lots of possibilities for making advanced materials out of nanocellulose and nanochitin.
Okay. And there is another question regarding the possibility to use these biodegradable nanoparticles deriving from the agro-waste as drug carriers, especially if a proper surface functionalization is applied.
So my group is actually working on making aerogels. So we make nanocellulose aerogels, and then you can introduce a drug into the aerogels for a sustained release. This is a very promising area. Sustained release of antibiotics, sustained release of drug using nanoscale aerogels, particularly cellulose and nanochitin. You can make beautiful aerogels. So that is a very promising field for drug release. And we are also incorporating nanocellulose in PCL and PLA. We do electrospinning. That would be an excellent material for the fold. And this base also could be utilized for sustained release of drugs.
I cannot see other questions from the public, but I invite all the people from the public to give a further question, because it is a unique occasion to do some questions to such an eminent scientist. So I invite everything in the public to give other questions.
Yes. Okay. Anyhow, I think that this discussion, hope that somebody else will take the occasion to ask questions, Professor Sabu Thomas. But in my opinion, this discussion have been extremely interesting and inspiring. Professor Sabu Thomas has a lot of energy, and I think his positive attitude is, so convincing for us. So we, many of us, I think, that are really convinced that it is worth to work in this field, and that bio resources are really have really a high potential for being exploited for producing new plastics. And we scientists should consider for sure the possibility to invest time and energy in this field. So I know that all the people know Professor Sabu Thomas. We know that he has a large group that is intensively devoted in the field, and I would suggest the people, the public, to follow him and follow his production, because it is something that is actually worth to do. So for the time being, if there is no other, there are no other questions. Yes. Do you have any more question, Andrea, to ask Professor Sabu? And if not, I would kindly ask Sabu to make.
There is excuse me, Elisabetta. There is a last question of the last minute. He say that if there are some rarely utilized agro-waste natural fiber. It's not a clear question. It should be interpreted in the sense that I'm thinking that are there some rarely utilized agro-waste as natural fiber? Do you know something about it? Do you have information about it?
Yes, there are lots of natural fibers to be explored. You're right. You see, I'm also looking in that direction. There are lots of natural fibers to be explored, to be understood. So I'm looking for new natural fiber resources where you have a high content of cellulose. That's a very important point. You see, if you look at Kottayam, the cellulose content is so high. But I am looking for some natural resources which is going to be a waste, which has got a high amount of cellulose. That could be very interesting. When you extract, nanocellulose from such resources, you could get more, you will get a high yield. So the question is very correct. There are lots of new plant resources to be exploited, to be found out. And you should really look at what could be the lignin content, hemicellulose content, cellulose content. Some of the fibers, I was told that the fibers are very strong. Of course, the fiber strength is depending upon the microfiber angle. And some of the fibers will give rise to high amount of nanocellulose. So I am looking forward to such plants where I can get high yield of nanocellulose.
Okay. Another question. The public don't want to finish this interesting event. So there is a question regarding the application of these biopolymer hydrogel for drug delivery. Are there some injectable biopolymer hydrogel for drug delivery?
This is very interesting question. Hydrogel is a very important platform for drug delivery. My co-worker actually, Gia, she did exciting work on hydrogel for drug delivery applications. So you can make use of nanoscale material for making hydrogel, and hydrogel could be a very good platform for drug release. It could be a good platform for wound healing application, and you can also do excellent chemistry, and then you can engineer beautiful hydrogels where you can have sustained release of different types of medicines. This is a very interesting question.
Another question. Maybe Professor Sabu is tired because he's talking for 1 hour, but the public is very curious. So this means that your answers were very inspiring. And there is a question regarding tie safety problems connected with nanoparticles inhalation. How much in economic terms the safety control related to the management of nanoparticle waste compared to the production of conventional materials?
The safety, right? Did you ask about the safety issues?
Yes.
The safety
associated to the use of
connected to the use of nanoparticle.
This is a very important question. That's very important. So we have to really take lots of care about safety of nanoparticles. Many nanoparticles, the surface of nanoparticles is so active. They have atomic surfaces. So their bits are extremely small. They can get into your body. They can break all the barriers. They can go everywhere. So while dealing with nanoparticles, we have to be extremely careful. Whether it is natural or synthetic nanoparticles, so we have to be extremely careful. We still have not really understood the effect of nanoparticles on long-term tissues. So I request all my co-workers, when you work with nanoparticles, you have to be extremely careful. You use multiple masks, you use gloves when mixing, dealing with nanoparticles, because we are not able to understand. Now, because the exposure of nanoparticles to human health, it could be short-term exposure, it could be long-term exposure. This is not well understood, and we are not able to really understand well what could be the size effect. What could be the shape effect? What could be the size distribution effect? So we really have to go a long way to understand the effect of nanoparticles on human health. Therefore, we have to take extreme care, whether it is single-ring nanoparticle or bio-nanoparticles. We might consider bio-nanoparticles are always biocompatible, and need not be. So we have to take extreme precautions, and we have to do a lot of studies, interaction of nanoparticles on human health.
Okay, there is another question that is strictly connected to the previous one. I don't know if you want to add something on this point, but the public ask, can you give some insights about the toxicity of nanoparticles deriving from agro-waste?
Yes, you see, we have not really found much toxicity on agro-particles derived from, nanoscale materials from agro-waste materials. If you look at nanocellulose, we could not see any adverse effect when we have done some in vitro and in vivo studies. We worked with the animals, we worked with the guinea pigs, so we found that most of these particles are quite comfortable. They are non-toxic. These nanomaterials, it could be nanocellulose or nanocrystalline or nanostarch. However, if you do acid hydrolysis or such treatment, we have to be careful about the residual acid, residual chemicals on the surface. So we have to do lots of cleaning process, remove all the residual components. If you do that, we have found that most of these nanoparticles are not toxic to human health. However, we still have to really look at what could be the long-term effect. I cannot comment on the bio-nanoparticles on long-term effect. What will happen after 10 years or 20 years? Therefore, I suggest that we have to be extremely careful about this. But many synthetic nanoparticles like carbon nanotube is quite toxic. Many metal oxides are quite toxic. And toxicity depends on the size. The smaller the size, the toxicity goes up because the surface is so active. So my message is we have to be extremely careful with all the nanoparticles, including bio-nanoparticles, because we do not know what is the long-term effect of these particles.
Okay, another question about economical feature of this nanoparticle, in the sense that they ask, the cost of biopolymer is a limiting use in the commodity application. Is in this sense the biomedical sector a promising area or a more promising area from an economical point of view?
Yes, you are right. Biomedical field is a very, very promising area using bio-nanomaterials and biopolymers. For example, PCL, PLA, and many interesting biopolymers have very, very promising application in medical field. Like polyurethane, biomedical polyurethane is extremely beneficial for heart valve applications. And many such materials, biomedical grade polymers are very, very important. That is very promising. We are also working in that direction. For example, with PCL, with PLA, such polymers are very, very important for biomedical field.
Okay, another question, a particular question, okay, that should be interpreted. What about the nanoparticle waste disposal?
Nanoparticle waste disposal. This is a very, very important question. How do you deal with nanoparticle waste? This is a very, very important question. So what we really do is, whatever nanoparticle we synthesize, these nanoparticles we mix with the polymers, and nanoparticles are encapsulated, when you mix with polymers. And nanoparticles, when they are free in the atmosphere, they aggregate. Nanoparticle surface is so active. So once they aggregate, they become microstructures, not very toxic. The microstructure surface is not very active. So disposal of nanoparticle is a very big challenge. I don't have any real answer to you right now how to dispose of nanoparticles in an effective way. Still, we have to do a lot of research on that. Disposing nanoparticles in a very efficient way. I still don't have any real answer for this question.
Yes.
Okay. Another question regarding the application of these nanomaterials deriving from the agro-waste for the cultural heritage conservation. You know that one of the main problems in the conservation of cultural heritage is the use of cellulose for cleaning works of art, since cotton scrubs leave residues on their surface. So hydrogen deriving from agro-waste, in the sense of nanocellulose, could be a suitable solution to this problem?
Yes, you're right. You know, cultural heritage, I mean, these materials are quite fascinating to preserve our cultural heritage. You're right. It's a very, very promising material because you are using, sustainable materials. So to preserve the cultural heritage, I'm sure, these bio-nanomaterials are wonderful base for preserving cultural heritage. I fully agree with you. Perfect.
Another question from the public regarding automotive application. So can you please give an insight about the application of agro-waste derived nanoparticles in the automotive industry? And in particular, what could be the future of rubber-based nanocomposites in the automotive field?
This is a very, very interesting question. I actually signed a contract with the biggest tire company in India, Apollo Tires. So we have two important products in our mind. One is the thread of the tire. You know, the thread of the tire now, the thread of the tire is the portion of the tire in contact with this, with the air. So it should have good resistance to abrasion. So right now, carbon black and silica are the main fillers. And they are quite polluting. So what we are going to do is replace carbon black and silica, make use of nanocellulose. And we do a lot of good surface chemistry to make nanocellulose hydrophobic so that it is compatible with this BR rubber or natural rubber. One application. The second application is use nanocellulose for automotive inner tube and inner liner. You know, automotive tires, we put air or nitrogen, and these nitrogen or air should escape. So we need an impermeable layer. So we are making use of nanocellulose, mixing nanocellulose rubber to make automotive inner tubes or inner liner. For tubeless liners, we are trying to make inner liners. This is a very promising application. So we will come out with a new technology using nanocellulose for tire engineering applications, both the tread and inner tubes. Similarly, we have ambitious program to make packaging films using nanocellulose and PLA, PLA-based blends to make beautiful packaging films, so that the transport could be reduced, and you can have very excellent membranes which are able to suppress the migration phenomena. So these are the key potential applications.
Okay, I cannot see other questions from the public, Elisabetta.
Yes. Yes. The public didn't want to let Professor Sabu Thomas stream because all of us are so interested in listening to him. But yes, for the moment there are no other questions. So I think that we are approaching unfortunately, we are approaching the end of this event. And I can only say again that, and I think that also Andrea agrees with me, that this has been a very interesting talk, very inspiring, very much inspiring. So I'm repeating my suggestion to follow Professor Sabu Thomas' production, because it is worth to do. For the moment, I can only thank both of you, both Professor Sabu Thomas and Professor Andrea Dorigato, for their availability, for participating in this event. Thank you so much. We are grateful. And I also thank the public for being with us for this night all throughout this nice event. And I invite you all to participate in next event of the Talking with the Scientist program. We will soon inform you about our program on our Milan Polymer Days Facebook page. So thank you again, and see you soon next time. Bye.
Thank you. Bye-bye.
Bye.
Bye-bye.
Bye.
Thank you so much.
Good. Thank you. Bye-bye.
Thank you.